Now, welcome back to my YouTube channel, Deeper Thinkers Tutorial. So now, we're looking at another drill. I think this is the drill we did in the last class. And this drill is quite simple. So we have xy equal 12 and sin y equals x and the rest of them. So how do we tackle this question? First, we have to observe the question. And if you observe this question, you discover that x is not, y is not expressed explicitly as in terms of what x. What we mean is that y is not the subject of what? The formula. Y is not the what? Subject of formula. So in that case, we'll be using what? The implicit differentiation what? Method. We'll be using what? Implicit differentiation method. So if I apply that method here, and I want to find my answer should be, looking at this, we have what? xy. So for me to differentiate, I will take x and differentiate it while keeping y constant. If you have not watched my video on implicit, look it up in the playlist. Now this should be, if you differentiate x, you should have 1 multiplied by, I will not touch y in the first instance, right? So I'll have x and 1 multiplied by y will give you what? Y, right? Plus. Then in the second instance, I'll come and take what? Y. And differentiate it, right? Then keep x constant. This will be x multiplied by 1, which will give you what? Y. No, which will give you what? X. Then you add dy dx. The reason is that you differentiated a variable that you are not differentiating with respect to. You understand? You are differentiating with respect to x, not with respect to y. So you have to add what? Dy dx attached to what? That derivative. Attached to what? That derivative. So now if you do that and you have equal to differentiating 12, on differentiating 12, you get what? A constant being differentiated will always give you what? 0. Will always give you what? 0. So in this case, we should have, if we're making, because we're looking for y, dy dx, you understand? We're looking for dy dx. I didn't state it, but you can say find dy dx in each of the following, on each of the what? Following. Now, so for you to get dy dx here, you need to move this y, right? Making sort of dy dx sort of formula. You take like terms and you move the y over to the other side to have this equal to what? Minus y. Now you can say divide both sides by what? X, which is the coefficient of dy dx. Or you can say divide both sides by x, or you can say multiply both sides by 1 over x, any of them. You have x cancelled out and x appears here. This cancels out. Dy dx is equal to minus y over what? X. And this is our final what? Answer. This is our final what? But I hope you know this is not the only way we can solve this. Do you agree? So what is the other way we can solve this? So if we want to solve it without applying the implicit method of differentiation, we can do what they didn't do. What did they not do? They didn't express y they didn't express y explicitly in terms of what? X. That means they didn't make y a subject of formula. So therefore, we can make y a subject of formula. So or making y subject, making y subject. What will we get if we make y subject? It will give you that y is equal to what? 12 over what? X. Right? Can you apply product quotient rule here? It's quite unnecessary. Hope you know. Because this can be written also as equal to 12 multiplied by 1 over what? X, right? Which you can further write as 12 x inverse. So if you find dy dx with regards to y being equal to 12 x inverse, according to general method, according to what? General method, the term here which is minus 1 we multiply what is in front, right? So if you know what my general method, video on what differentiation, you should look up that. Anytime you are differentiating a term like this using general method, what is the power of x? We multiply its coefficient. You understand? Which will give you minus what? 12. Then, in this case, we have what? X minus 2. And that's the final answer. That's what? But somebody will ask me, this and this, are they not looking? Are they the same? So what is the difference? Remember, we said that y is equal to this, right? Okay. This is what we got. From this place, we can say that both y is equal to 12 over x, which is 12x inverse. Substitute the value of y here. You have dy dx equals to, therefore, dy dx equals to minus 12, okay, let me just write it, 12x inverse over x. What will it give you? Minus 12x, this guy, according to indices, if you remember, will be minus 1, minus 1, because it has a power of 1, and they are dividing. Which gives you what? Minus 12x minus 2. What is the difference between it and this? So what you get by implicit differentiation is still the same thing you get when you express it explicitly. Explicitly, you get the same thing. I know most of you, when you saw it, you thought maybe I have made mistake or I'm stuck, right? But you discover I'm not stuck. I know what I'm doing. Now, let's look at this. I might not do this for all the questions, you understand? So avoid taking much time. Because if you have gotten this, your lecturer will mark it. So you still decide to do this, your lecturer will mark it. But it's preferable you do this. Because this question is easy. That's why it's easy for us to express explicitly and go forward. You understand? But if you come to a question like this, hope you know there is a problem. This one, there is a problem trying to express explicitly. Because it involves a lot of things. So what do I do now? Let me take out this and let us solve the next question. What do we do here? We differentiate implicitly, right? Which will give you cos, that's minus cos. Okay, cos, because the standard derivative of sine is cos. So cos y, right? Then since you differentiated y, you have dy dx. Then equal to differentiating x, you have what? 1. So it means that what? Your dy dx is equal to what? 1 over cos y. So that's the final what? Answer. But you can still implement the same concept and say, making y solve the formula, take sine inverse of both sides. So y is now equal to sine inverse of x. So you now do derivative of what? Sine inverse. So I need to teach you that one also. How to differentiate inverse 3 functions. Inverse what? So if you have that knowledge, you can easily apply that. But we won't be going into it. This is already okay. This is what? Already okay. Now let's come to what? The third question. You see how cheap it is now? This didn't take me up to 1 minute. Now on differentiating this, what will I have? If I differentiate x, I'll have 3x squared plus, differentiating this, 3y squared. But because I touched y, I'll add dy dx equal to what? 0. Now, making dy dx solve the formula, I take this over to this side, right? 3y squared dy dx will be equal to what? Minus 3x squared. Then if I divide both sides by this, right? Divide both sides by 3y squared, I'll have here to be 3y squared. So 3 will cancel 3, right? Finally I have minus x squared over y squared. So this is the final what? Answer. This is the final what? So let us can we clean this place? Okay. So having this out, what do we have? So for the next question, we have this, right? Yes. Which is IV. What do? We have E, that's exponential y plus x equal 5. So what is the first step you think we should take here? For us to differentiate this implicitly. If you have to differentiate exponential, what do you have? You can say, wait, let's see. You can say this will give you, if you differentiate this, you will have 1, then exponential y dy dx plus 1 equal to what? 0. Right? So now this will give you exponential y, because if you multiply this, you still have exponential y. Dy dx is equal to minus 1. So that dy dx is equal to what? Minus 1 over what? Exponential y. Is that not the case? Which you can write as exponential minus y, then you put minus here. Are we wrong? No. Inverse, 1 over something. But there is another way we can what? Solve this. And that method is by what? Making y the solid of what? Formula. Making y the solid of what? Formula. And it should still give you the same thing. Right? For you to make y solid of formula now, you need to first, segregate x from these points. So that everything will be what? Defined in terms of this what? Value that carries y at the what? As the power. So I can bring down the y and make y the solid of the what? The formula. So now if we do it, we can say, or, here we collect like terms and we have exponential y is equal to 5 minus x. Are you understanding? So we want to take everything outside so that this will remain. You understand? So that we can now tackle the y being up and bring it down to become a base. Do you understand? So to do that, what we take what? What do we take? Ln of both sides. Take ln of both what? So taking ln of both sides, we should have ln exponential y is equal to what? Ln 5 minus x. Are you there? So on doing this, now if we take ln of exponential, first, that ln of that exponential will cost the ln of exponential something. We cause that thing on top, which in case our own case is y, to come down. You understand? So it's just like saying what? Log of a value that has a power. You understand? That power will go down. I normally write this in my videos. So I have this and this to the power of, let's say, x. When you do this, now this power can come down and become what? X. Right? So this is what we can have. So if we implement it here, we have what? We have y ln exponential equal to ln 5 minus what? Is not what we have? Ln of exponential will give you what? 1. So we have, since it will give you 1, we have 1 multiplied by y is y. Then here we have this, right? So if we now have this, we can now say that y is expressed explicitly in terms of x. So we can now find dy dx. On finding dy dx, we implement the concept of linear derivative, right? Which is differentiate what is here. You will get what? Minus what? 1. Is that not so?
Yes.
Because this will give you 0. This will give you 1, which is minus 1. Over, rewrite what is here. By so doing, you have successfully what? Differentiated this. So once you have done this, you can say you have got your final what? Answer. You have got your final what? But someone can come and start arguing that, sir, this is not the same as this. Right? You might be correct in terms of what looks, but you are not correct in terms of what? The ultimate what? Value. The ultimate what? Value. You are not correct. Because if you look at this is the same thing as saying exponential minus into ln 5 minus x. Somebody will ask me, where did you get this? Remember where I get it. I said, recall that but y equal to what? Ln 5 minus what? X. Remember, we are dealing with this now from here. From here, right? We get this, right? And we know that but y is this, right? So we implement. We what? We implement. Do you agree with me? We implement. So this will give you what? Exponential minus ln 5 minus x, and that is it. Then anytime we have something like this, remember this can be written as minus 1 multiplied by ln. Hope you agree. Minus 1 multiplied by ln. You agree, right? The same concept we implemented in taking down the what? The power from this place to the back. Do you understand? We can also implement it here to take this power up to this place. Do you agree? This power, the ln can bring it down here. If it is down here, I can also take it up here. It's still the same what? You understand? It's still the same value. So we can have this to be minus exponential ln 5 minus x all to the power of just like this y is. You know the way this y is the way this 5 minus x is, Abi? Then it's now be raised to power this. Do you agree with me? Exponential carrying y. That's the way this ln is. So anything at the back can come here. Do you understand? So in that case, we can have exponential of ln, we cancel out, right? What we have? Minus 5 minus x inverse. Do you agree? This will be the same thing as saying 1 over. Anytime you see a power of minus 1 over, remember there is minus here, right? 5 minus x. Is it not the same value? This is the same as saying this. Remember, minus. They will have raised to power 1 minus 1, which is 1 over everything here. Then the minus in front is the same thing as this. Do you agree? Do we agree? So that is that for that. Now let's for the last question we have this, right? On implementing the concept of implicit differentiation, we can still have the same concept. If you are to differentiate this, if you are to what? You will have, or should I give you as a take home? Yes. Okay. So let's just do it. I'll give you as a take home is what? Making y the subject and working on it. So we have this now. If you want to differentiate this, you work on this, yeah, right? Work on this. I'm working on this now. Since they are multiplying themselves, you differentiate x and leave y. If you differentiate x and leave y, you have 1 multiplied by what? Differentiating x, you have 1. Multiplied by y, you still have what? Y. You write it down. Cos, which is the standard derivative of this, x, y. Are you understanding it? Plus, because it's a product rule concept. It's a product what? I explained it initially that the reason why, if you have 2y here, if you have what? This y to be maybe like, say, let's say 2, and it becomes what? 2x. The reason why you are not doing this is because if you do the second process of it, where you will not touch that 2, the 2 will go to 0. So it will be also the same thing as not doing it at all. You understand? But in this case, since it's a letter now, something will happen. It will have a value. You understand? So you can't just throw it away. So if you are touching y in this case now, so you touch what? Y. Differentiating y, you have 1. 1 multiplied by x will still give you x. You write down that x. Find a standard derivative of the sign. You still get cos. Then write what is in front. X what? Y. But because you touched y, you attach dy dx. Then everything will be equal to, differentiating this, you get 1 plus 0. Wait, okay, yeah, you have what? 1 dy dx. What entered my head that made me say 0 is in partial derivative. You might see touch that area. Partial derivative, that's when you have 0. But you don't need it now. Okay, so having this, you want to make dy dx the subject. And to do that, you have to bring all the dy dx values close. You understand? So I'll collect lightens, I will CLT. So now on collecting lightens, LCT, we have what? We take all the guys with dy dx to one side and all the guys that don't have dy dx to the other side, right? So this guy is with dy dx, so I'll have cos x y dy dx minus 1 dy dx equal to 1 is already on the other side already, so I'll write 1. Remember, this guy has x by the side. You understand? This x here is for this, right? So if that is the case, we have 1 here. Then this one, taking it over to the other side, to give you minus y cos x y. Is that not? Any other thing we are missing out on? No. So here now, since this has dy dx, this has dy dx, I can bring them together and factor out dy dx to have cos x y, that's x cos s y, minus 1 into dy dx. Everything is equal to 1 minus y cos x y. Right? So we should have dividing both sides by anything apart from what? Dy dx. We should have 1 minus y cos x y over x cos x y minus 1. So this is our final answer. So thank you for watching. Like, subscribe, comment, and share with your friend. And see you in our next video on integration. Thank you for watching.